Hello grade 11. Today we're going to start a new chapter which is alkenes, alkynes and benzene, and today we're going to start with alkenes, the first part. The objectives of our session today is to define an alkene, use the IUPAC nomenclature rules to name alkenes, and identify the different types of alkene isomers. Definition. Alkenes are hydrocarbons. This means that they are made up of hydrogen and carbon. They are unsaturated. Unsaturated means then they have a double bond. So alkenes are characterized by a single double bond between two carbons. So they are characterized by what? A single double bond. This is a single double bond between two carbons. Their general formula is CnH2n, and their functional group is the double covalent bond. So we can characterize them by their double covalent bond, which is present once in an alkene. So we have a single double covalent bond. Okay, so the IUPAC nomenclature. The name of an alkene that has the longest chain containing the double bond is derived from alkane that has the same number of carbon atoms, replacing the suffix "ane" by "ene". For example, we said that ethane in alkane, it will be ethene. The propane will be propene, depending on the number of carbon atoms. Okay, so we have many rules, many cases. The first case is for n if n is less than 4. Note that n كمان should be greater than 1. لأنه C1, we don't have C1 لأنه if it's only one C, it cannot make a double bond with another carbon. So alkenes, they start by n equal 2. Okay, so for example here we have C2H4, so CnH2n. This is the structural formula, the condensed structural formula of C2H4. The name of this is called, how many carbons we have? We have 2 carbons. So in alkane it was ethane, so now it is ethene. Okay, the second one, C3H6, so CnH2n. So here, look here, where do we have the single bond? We have it between the first 2 carbons. And here, if we have it here and we didn't have it here, it's the same. It will be between the 2 carbons, and we will number them according to the the double bond takes the least number. Okay, so the name, it has how many carbons? The 3 carbons. So its name in alkane it was propane. So here it is propene. Okay. Now, the second case, if we have an n is greater than 4, okay? If n is greater than 4, we have 2 cases in this. In case of a linear alkane, so linear alkane means it doesn't have any branches. We number each carbon in the linear chain so that the double bond, covalent bond, is between the least numbers. For example, let's say we have here 4 carbons, okay? So, and the double bond is here, okay? So we for example, let's count them here, number them, 4. So here the double bond is between 3 and 4, okay? Let's number them in the opposite side, 2, 3, 4. So here كمان the double bond is between 1 and 2. So we number them, we will take between 1 and 2. So that the covalent bond is between what? The least numbers, okay? So we take this direction while numbering. So before writing the name of alkene, you should indicate the position of this C double bond, okay, or double covalent bond between the carbons, okay. So you should indicate. طب here the position is between 1 and 2. What do you write? You write 1. يعني you indicate the position is 1, not 2, okay? Okay, so we have here examples to solve. Let's see the first one. The first one, we have 4 carbons, okay? So the double bond is between, let's first number them. 1, 2, 3, 4, and we number them in the opposite direction. 1, 2, 3, 4. So if we numbered from left to right, we have that the double bond is between 1 and 2, and if we number them from right to left, we have that the double bond is between 3 and 4. So what do we choose? Which one between 1 and 2? لأنه هن least numbers, okay? So we take the least numbers here, 1 and 2, and we said we have to take the least number in determining or in indicating the position of the alkene. So we have 4, so it's butene, and the position is on carbon number 1, so 1 butene. Okay, the second one, let's number them. Let's number the carbons, the carbon atoms. Here we have, they are 4 carbon atoms. Let's number them in the opposite direction. Okay, so we have here, they are, the double bond is between 2 and 3 in both directions. So we have 4 carbons butene, and we choose the less number, sorry. So the less number is 2, so it's 2 butene. Okay, so we have now the third example. The third example, let's number them. 1, 2, 3, 4, 5. Let's number them in the opposite direction. 2, 3, 4, 5. Type. Here the double bond is between, if we number them from left to right, we have the double bond is between 2 and 3, and from right to left they are between, the double bond is between 3 and 4, so we choose 2 and 3 and 2, so 5, it's pentene, so 2 pentene. Okay, the last one here, let's count, let's number the carbon atoms. 1, 2, 3, 4, 5, 6, 7. Let's number them in the opposite direction. 1, 2, 3, 4, 5, 6, and 7. So 7 carbons, it's called heptene, and we have between the third carbon and the fourth carbon, if we numbered them from right to left, and between the fourth carbon and the fifth carbon, if we numbered them from left to right. So we will choose between 3 and 4, and it is what, so it is a 3 heptene. Okay, so the second case, if we have, in case of branched alkene, what do? We circle the longest chain having the double bond, of course. We number the carbon so that the double bond takes the least number. So here we have to number, in alkanes we number them in order to take the branches take the least numbers according to their alphabetical order, of course, but here we should only take into consideration the double bond. So the double bond should take the least number, the less number. Okay, so after that we indicate the allocation of the alkyl group by the number of the carbon atom to which they are attached. Okay, so let's apply this rule on some examples. Okay, we have this one. This is an alkene, and it has one double bond. So we circle the main branch, we number them, number the carbon atoms present. So 1, 2, 3, 4, 5, and let's number them in the opposite direction. 1, 2, 3, 4, 5. Okay, so if we consider the counting from left to right, so it's between 2 and 3, and if we consider from right to left, it's between 3 and 4, so we will choose 2 and 3 because it takes the least numbers. Okay, so we have here 2, so the double bond is on carbon 2 and it is 5 carbons, so pentene, and we have a branch on carbon number 4, so 4 methyl 2 pentene. Okay, now the second example. Okay, let's circle the main branch here لأنه it contains the longest number of the greater number of carbons, يعني it's the longest chain. So we have here 1, 2, 3, 4, 5 carbons, and let's number them in the opposite direction. 1, 2, 3, 4, 5. So if we consider the numbering from left to right, they are the double bond is between carbon number 3 and carbon number 4. If we consider the numbering from right to left, the double bond is between 2 and 3, so we will choose 2 and 3. So here we will choose that it is how many carbons? 5, so it's pentene, it's on 2 pentene, so on carbon number 2 the double bond, so 2 pentene, and we have 2 branches on carbon number 4. These branches are methyl, so 4,4 dimethyl 2 pentene, 4,4 dimethyl 2 pentene. Okay, we have here another example. So we have, let's circle the longest chain containing what? The double bond. Okay, so we have here 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. It's the same, so it's better, it's easier to take the straight one. Okay, so let's number them. 1, 2, 3, 4, 5 in this direction, in the opposite direction. 1, 2, 3, 4, 5. So here if we considered counting from right to left, it's between 2 and 3, and from left to right it is between 3 and 4, so it's better to take 2 and 3. So we will consider counting to this direction, from right to left. Okay, so we have branches. What do we have? We have Cl, Br, CH3 methyl, and CH3, which is methyl type. Okay, so we said we're going to consider this this direction. Okay, so first of all, what are, if we have more than one branch in like alkanes, we consider the branches, we write the branches according to their alphabetical order type. What do we have here? Bromo, chloro, and methyl. يعني B و C ومثل M type. So first of all we call B, bromo. طب البرومو is on carbon number 1. Remember we took this direction from right to left. So 1 bromo, after B we have C. So 4 chloro, and we have 2 methyl groups on 2, 4 dimethyl what? 2 pentene. Why 2 pentene? Because it is between 2 and 3, and we take number 2. Okay, we have here last example, which is here what do we have to circle the main chain. طب let's count. 1, 2, let me put a dot, 2, 3, 4, 5, 6. طب I'm gonna choose another color. 1, 2, 3, 4, 5, 6, 7. So which is better, 6 or 7؟ احنا قلنا بدها تكون greatest carbon, so 6 هيها 7 sorry. Okay, so this is the main chain. So the main chain, it doesn't necessary to be a straight one. This is the main chain لأنه it has the greatest number of carbon atoms and it has the double bond in it. Okay, so CH3 CH هيدي كلياتها is the main chain. What are the branches? We have this one which is methyl, this one which is methyl, CH3 here it's methyl, and here CH2 CH3 it's ethyl لأنه it's C2H5. Okay, so let's number them. How do we number them? We number them in a way that the carbon, the double bond takes the least numbers. طيب here 1 2 3 4 5 6 7. طيب in the opposite direction 1 2 3 4 5 6 and 7. So which direction we use? We use this one. Why? Because 3 and it's between 3 and 4, so it's 7, so heptene, and on carbon number 3, so 3 heptene. Type, let's see the branches. We have methyl and ethyl. Which is first? Ethyl, of course, right? So ethyl is on carbon number 4, so 4 ethyl. And what do we have? A trimethyl. طب هود الترايmethyl, they are on what carbons? We have them on carbon number 2, 2, 3 and 5. So the name of this compound is 4-ethyl 2,3,5 trimethyl 3-heptene. Okay, so let's now discuss the types of alkene isomers. Alkene isomers, أول شيء we have to recall what are isomers. Isomers, they are compounds that have the same molecular formula but different structural formulas. Alkene isomers are of 3 different types: positional isomers, skeletal and geometrical. Positional isomers, they differ in the position of the double bond. Skeletal isomers, they differ in the branching or the main chain, and the geometrical isomers, they differ in their arrangement in space. So positional isomers, they have the same functional group, which is the double bond, but it differs in the position of this functional group. The skeletal isomers, they have the same position, of course the same functional group, so this and the same position, but they differ in the branching or main chain. Okay, the geometrical isomers, they have the same functional group, which is the double bond. They have the same position of the double bond, and they have the chain, but they differ in the arrangement. يعني arrangement of the atoms around the double bond, it differs between the geometrical isomers. Okay, so let's consider here we have 4 isomers of butene, sorry, C4H8. So let's name them. This is 1 2 3, so 1 butene, the second one is 2 butene, and the third one is 2 methyl propene. Okay, طيب let's see A and B. A and B هن 1 butene and 2 butene. How do they differ? They have the same number of carbons, of course, they have this they are isomers, but they differ in the position. Here the position is between carbon 1 and carbon 2, and here the position of the double bond is between the carbon 2 and carbon 3. So they differ in the position, so they are called positional isomers. Okay, so these are the positional isomers because they differ in the position of the double bond. They have the same group, the same functional group, and they just differ in the position of this group. Okay, let's see A and C. Type A and C, they have the same position of what? Of the the double bond. Here the double bond is between 1 and 2, and here between 1 and 2 carbons 1 and 2, and what? And here we have the A is linear while C is branched. So they are called the skeletal isomers. Why? Since they are different in the chain, they have different chains. Okay, A is straight while C is branched. Here is linear or straight, and here it is branched. Okay, so positional isomers, they differ in the position of the double bond. Here we have skeletal isomers, they differ in the chain, in the if it is straight or branched. Okay, هلا geometrical isomers, they are also called the stereoisomers. Let's consider the case of 2-butene. 2-butene here, as you can see, it has 2 stereoisomers. Okay, 2 stereoisomers are possible. One stereoisomer is called cis-2-butene, and the second one is called the trans. Now, let's look at cis. What do we have here? We have the H groups, this double bond, the C, the carbons of the double bond are attached to 2 H's and to 2 methyl. Each carbon is attached to 1 methyl and 1 hydrogen. So they are the carbons holding the double bond, they hold what? They hold the same atoms or the same groups. Here H and H. Type. The cis stereoisomer has both of the double bond hydrogens on the same side. So they have them, the hydrogen atoms, they are on the same side. That's why it's called cis. Okay? While the other stereoisomer, which is a trans, has the 2 hydrogens on opposite sides of the double bond. So they are on opposite, that's why they are called trans. Okay? هلا we can say instead of trans Z, and instead of instead of cis Z, and instead of trans E. Okay? So when 2 identical groups, these identical groups, they can be methyl هون or here hydrogens, are on the same side of the double bond, the molecule is said to be cis or Z type. Here they are on what? On opposite sides of the double bond, the molecule is said to be trans or E. Okay, so when you see Z, so it is what? It is a cis stereoisomer. If you see E, it is trans. Okay, the condition we have along the double bond, there should be 1 hydrogen only on each carbon. So along the carbon, the double bond, we should have only 1 H, and the other, the C is a tetravalent, so it has 2 double bonds here, and it needs 2 single bonds more. So one of the single bond must be attached to a hydrogen group, and the second one is to a different group. Okay? Geometrical isomers, they occur due to restricted rotation of the C double bond. So we have a rotation, but it is restricted because we have 2 double bonds. In alkanes, we cannot have stereoisomers. Why? Because on the single bond you cannot have because we have a rapid rotation, a free rotation on on the double bonds. They rotate. Okay, so just here you have to know that we have 2 stereoisomers, cis and trans, and the trans if they are on opposite directions, cis if they are on the same direction. Okay, so let's here draw the condensed structural formula of 4-ethyl 5 methyl 2 hexene. طب hexene so carbon C6. Okay, so okay, so it's between what? It's on carbon number 2. So the double bond is between 2 and 3. 1, 2, 3. So it's here. Type. On number 5 we have methyl. So 1, 2, 3, 4, 5. So here methyl CH3. And on number 4 we have ethyl. Ethyl, it's what? C2H5. Now we complete by writing the H's. Here it needs 3. Here 1, 2, 3, so it needs 1. Here 2, it needs 1. Here 1. 1 and CH3. Okay, here we have a last application in our session today, which is draw all the possible condensed structural formulas of isomers of C4H8. Okay, so first we have to, before writing the isomers and drawing the isomers, we should classify them into positional, skeletal, and stereo isomers. Okay, so let's first start with the positional isomers. So let's start with the first one. Let's say انه هي C4, so 4 carbons, and we put the double bond in between, يعني the first and the second. So here it's CH2, CH2 and CH3. So it's between carbon 1 and 2, so it's 1 butene. The second one, in the positional, we just change the position of the double bond. So instead of putting it between 1 and 2, we put it between 2 and 3. So let me first write this is the double bond. So let's complete it by the number of hydrogens. CH3, here it needs 1, and CH3. So it's between carbon 2 and 3, so it's 2 butene. Type. Can we do other positional isomers? Type. Let's say, for example, we put it here. It's the same. It will be the same as the first one. Okay? So these are the 2 positional isomers. Hala, after writing the positional isomers, we should go to the skeletal isomers. Skeletal isomers, we do a branch. Type. First, we look at the positional isomers. Which one can we make branch using it? Double 1-butene, if we took this branch and put it here, or this one and put it, we cannot. So, 2-butene we cannot take, لأنه we will not have the position of the double bond here. Okay, so the skeletal isomer, we will have, we said that it's like 1-butene. So here, okay. طب نحن قلنا we took what? We will take the carbon, the third carbon to make it, the fourth carbon to make it a branch. So here, so CH2, here it's tetravalent already, so CH3 and CH3. So the name of this skeletal isomer is what? We have 2-methyl-propene. طب انتوا you will tell me طيب يا مثلي why we didn't write مثلا 1-propene. ما remember نحن in n less than 3 we don't indicate the position of sorry, in n less than 4 we don't indicate the position of the double bond. Okay, so it's 2-methyl-propene. Okay, now we go to the stereoisomers, but before going to the stereoisomers. Which one of the positional isomers we can make it what? We can make it a stereoisomer. نحن we said the condition of making a stereoisomer that along the double bond we should have one H on each carbon. طيب, this one we don't have one H on each. We have here one hydrogen and here two hydrogens, so we're not going to use it أصلا for stereoisomers. Okay, we will look to the second one. طيب, the second one we have here one hydrogen and here one hydrogen, so we can use it. Okay, so stereoisomers, I said we're going to use this one, and we have one H and one H, and we still have CH3 and CH3. These are called what? This is called what? The hydrogen atoms are on both sides, so they are cis butene, 2 butene, لأنه 1, 2, 3, 4, so they are between 2 and 3. And the second one, we will make them trans. So C double bond, C, H here, and here they are on opposite sides. So here is CH3 and CH3. They are on opposite sides, so they are trans. Instead of cis, we can write Z here, and we write Z, of course, between parentheses, and we write this dash 2 butene, and the trans, instead of trans, we can write E 2 butene. Okay, so by this we ended our session for today. If you have any questions, don't hesitate to ask me, and goodbye.